Let's do that. Okay, so here we have a little bit, and they said the diagram shows a uniform beam PQ. The length of the beam is 3 meters, weight 50 Newton. The beam is supported by a pivot 1 meter from end P. A load of weight W is hung from end P, and the beam is equilibrium. So what you needed to recognize is you need to add the weight of this beam. They do tell you it's uniform, so it means it's right in the middle. That means 1.5 meters from the one side and 1.5 meters from the other side. Weight is 50 Newton. Once you have that information, now it becomes a quite simple calculation where you say, well, the sum of clockwise moments equals my sum of the anti-clockwise moment. And do you know what? I would like you, when you work through questions like this, not you do it on a quiz like that, but separately, do the writing out, because then you're also prepared for the structural question paper. So clockwise, turning it clockwise, this is 50 Newton, it's 0.5 meters from the pivot where it is. And my W is turning anti-clockwise, 1 meter W. All right, so that means 25 equals W. My weight is A, 25 Newton. Okay, so a relatively easy question by standard. With that, any questions? Guys, as we go along, just give me an indication. I know
Sir,
you talk too much, except Liam. Hello, Liam.
This time pressure should not be allowed. I feel so stupid.
Listen, sorry, I'm going off topic again. Those of you who have chemistry, you have an hour and 15 minutes for physics. Okay, gives you that 15 minutes extra. For chemistry, for the 40 marks. For chemistry, you only have 1 hour for the 60, for the 40 questions. You've got 15 minutes less. So your time pressure is even worse than me. Just
I literally.
We can be quiet.
Right. So let's look at the next one. Two forces, magnitude F, act at a point V, right, on an object. The two forces from a couple form a couple. So a couple refers to a force couple. Right. What is a force couple? Force couple says, well, it's a specific situation that's going to rotate around that point because my two forces, equal force, is turning around it. Still, my definition for that is force times one of the forces times the perpendicular distance between forces. Remember, if we were just working with a normal moment, it would be the distance to the fulcrum. Over here, my definition is slightly different, and it's a force times the perpendicular distance. That means it's F times Y, and B is my correct answer for that. Right, let's move on to my pendulum bob. Right, so a pendulum bob is held stationary by a horizontal force H. The three forces acting on the bob are shown in the diagram. Okay, so here we can draw our triangle. Now, I know you don't have time to do it in this sense, but listen, you don't have to in this case. For many of you, it would be a relief. Don't use your ruler. We know there's a force going down, that's W. We know there is a horizontal force, so there's my Cartesian plane, where's my horizontal force, H. And then there is the tension going back, so again, tension going back, that's T, and I have this 30 degrees up top. Right. So now they ask you which statement is correct. Now, before you look at the multiple choice, my 30 is not coming out, write down what you can get from it. From that 30 degrees, because in the answer they only use 30 degrees. So if I want to calculate W, how is W related to T? Well, W is equal to T cos 30, because it's adjacent. My H is T sine 30 degrees, because it is opposite to that. So this is the true statements in there. So going back to my choices, no, 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 yes, D is my correct choice. So it's always better to, because this is set up to confuse you. So it's better to have your diagram, and from your diagram, get the information and then go check. Better way around to do it. Any questions? Right, let's move on swiftly. Right, here we go. A uniform ruler or rule, weight 2 Newton, is pivoted at the 60 centimeter mark. A 4 Newton load is suspended from one end, causing the ruler to rotate about the pivot. This means this is not an equilibrium. So we cannot fall back on our rule that says sum of clockwise moments is equal to sum of anti-clockwise moments. We need to go and calculate each moment on its own. The 4 Newton is going to turn it clockwise. So let's calculate the clockwise moment. So clockwise moment, wow, equals 4 times 0.4. 0.4, how do we get to that? Well, it's from the end of the meter ruler to 60 centimeters. So it's 40 centimeters. We need to work back to meters. It gives me 1.6 Newton meter. So that's my clockwise moment. My weight of the ruler is going to turn it in the opposite direction. It's going to turn it anti-clockwise. So again, anti-clockwise and moment equals 2 times the 0.1. It's only 10 centimeters away. What does that give me? 0.2 Newton meter. So what is my resultant? My resultant is 1.4 Newton meter, because that bit of turning moment to that side subtracted from this side, remember it's still direction, therefore ending up with a net torque of 1.4 Newton meters turning or tending to turn this clockwise. Let's get to our vertical forces that's exerted on this van. So we have a van. The van is 2.5 meters long, with the wheels at a distance 0.6 from the front and 0.4 meters from the rear end. What is the horizontal distance of the van's center of gravity from the front? So they're asking us, where is this weight working in? They give us the additional information of this 9,000 Newton that's pushing up against the back wheel and 16,000 Newton working against my front wheel. Can we, by knowing that, calculate the weight of the truck? Because our unknown, we still got to use moments. My unknown in here is actually where the distance is. Because just looking at the two weights or two forces over there, this is not a uniform beam, and neither we know a truck or a car, something like that, it's not going to be uniform. There's an engine in the front and an empty boot, so this is not going to be in the center. like many of you took it. So we need to find that distance. We can find the weight. Why? Because we know this vehicle is moving up or down. I know that my resultant force is 0. So since my net force is 0, my resultant force, I know my forces of up is equal to my forces down. So literally 9,000 plus 16,000, the weight of my truck is equal to 25,000 Newton. Now we can take the moments around a point. And I'm going to take my moment around my front wheel. As soon as I take that as my pivot, remember, if a force is at the pivot, it's not going to tend to rotate it. It's at the pivot. So then we can ignore that force. All right. So now we are going to take my weight is going to tend to turn it clockwise around my pivot. And the 9,000 Newton is going to tend to pivot it anti-clockwise. If this was a structural question, the top part would have been necessary. Also, the next that you tell me, well, I'm going to take my moment around the front wheel. Right. So let's do this. Let's say clockwise with my clockwise moment equal anti. I can say this because I know my truck is also not rotating. It's standing still. Clockwise is the weight of the truck. It's that 25,000. And I actually want to know X, the distance to that pivot. If I have distance to the pivot X, I can add my 0.6 and I know how far it is from the front. All right, my other force is the 9,000. It is 1.5 from that pivot. And I get X as 0.54 meters, well, to the pivot. Adding 0.6 plus the 0.54 gives me my total meter of 1.14 meters. So a slightly more complex question that you had to do a lot for. Right? Happy? Right? Okay. If I see Sean's hair waving like that, I know we can go on. Right.
So where's the recording going to be of this Zoom meeting?
Do you know what? I'll put it for you on YouTube, since I'm afraid I'm going to bust Moodle if I do that.
Okay. Thank you.
Pleasure.
Please put on Moodle.
No, because I wanted to do the quiz still on chemistry. Right. Listen, this was a humdinger of a question. This was challenging. I don't know. I found it challenging because they don't give us a lot of information. We have this object that is 10 Newton. And then we have this angle of 90 degrees, the whole angle in there. We've got a F2 and we've got a force F1 in there. And that's actually all that they give us. They don't give me anything else. If I go and draw my force diagram, boop, boop, that's my 10 Newton in there. This is my force F2, and that's my force, F1. Where's my? And I know this is 90 degree angle. Because I know this, I can use Pythagoras. And the rule for Pythagoras, squared plus 2 squared, it must give me 10 squared. The only options that support that is if we have a force of 6 and 8 Newton and 6 and 8 Newton. That's the only information that we have. Now, for the rest, you need to look what is happening. They don't say this is not to scale. They also say it's to scale because there's no real weight in there. But look at your F2 relative to your F1. F2 must have a greater force than F1. Think of you having two strings. If you let the one slip slightly, it's going to drag down to this side. So your F1 should be the smaller one of the forces, the 6 Newton, while F2 must be the 8 Newton. This is the only way you can solve this question. There's no other way. Questions? Just doing that.
But so how do we know the values of them again? How do we do that?
You need to look at what they
Pythagoras.
actually you substitute in 4 squared plus 6 squared. What did that give me? Well,
oh, okay, I see.
4 squared.
Oh, so you have to actually.
Yeah, you need to actually test what it give me. There's no other ways because there's a very few options that might give you 100, but only the options that given here, 6 and 8. So 6 squared plus 8 squared, 64 plus 36 gives me 100. Only 2 options available. But
all right, okay,
which one is which now? Well, F2 is greater than F1. So I'm just going to say F2 is greater than F1. And therefore...
So here we actually have to look what they give us in the multiple choice.
Yes, you do. You know what? This is not, obviously, for you guys, this is the first case like this, but yes, a lot of the time, this is how they do it. And this increases the complexity of the question. Happy? Not really, but, you know, at least this is next. Okay. Diagram shows 4 forces applied to a circular object. Which row describes the resultant force and resultant moment? So nice, they don't give us values. They just want to know, is there a resultant force? Is there a resultant force? Do you have a shirt on, Liam? What's happening there? Sheesh. Gee, I can still see exposure, right? Shivered. Right. Let's look at this question. I can see a torque couple, a force couple. Look at this. This is a force couple. So force couple tells me there's going to be a net moment due to those two. So immediately there is going to be a non-zero and a non-zero value in there. For my 30 Newton, there's actually no net torque for that. But what is there? Well, it's, if you consider this to be a point source, it is a 30 Newton and a 30 Newton pulling it to the one side with no force to the other side. So there's also a resultant force, a non-zero. Therefore, there is a resultant force. If I look at my 45, just for up and down forces, that cancels out. So there's actually a net force pulling it to that side. And there is a net moment or net torque doing an anti-clockwise. Sorry, clockwise. Wow, where are we? Clockwise moment. There's a clockwise moment.
So Jan has a question.
So A is the correct answer. Yes, ask.
When will torque be 0? When will be the result 0?
So if it was just for the torque and we consider the 30 Newton, 30 Newton, that torque would be 0. So torque and
Okay.
turning moment would have been that. So for that, the turning moment is 0. Happy?
Yes, thank you. Yes.
Okay, no worries. I lost a few of you. Internet connection seems to be also a bit of a slight issue. Okay, we've got, what's it, one,
Don't
two.
worry, sir. I got no internet connection issues.
You have internet issues? No, not really. Okay, so let's move through this. In which example is it not possible for the underlined body to be in equilibrium? An aeroplane climbs at a steady rate, constant velocity, constant displacement per time unit, so it is possible to be in equilibrium. An aeroplane tows a glider at constant altitude, so because it's not changing direction, for instance, yes, it is possible. But now see where it changes direction, it is not possible to be in equilibrium. Remember, once you change direction, a vector, direction, magnitude, okay, therefore not in equilibrium. The last one is so open to any interpretation. A boat or two boats tow a ship into a harbor. Well, it could be at constant velocity, it could be anything in there. So very much open. So C is the one that's absolutely not possible. Right, I don't think any one of you have an issue with that. Let's look at the next one. Definitely some serious issues, I believe. Let's look at it. I've had many serious issues with this previously as well, and lots of discussions in class. So the speed of an aircraft in still air is 200 kilometers per hour. The wind blows from the west at a speed of 85 kilometers per hour. In which direction must the pilot steer the aircraft in order to fly due north? Okay, due north. Let's quickly see what we have here. First of all, you need to know your geography, right? West and east, north and south. I don't give that to you, you need to know it. So we, for those of you who don't have geography, if you just we on your page, it is fine, you get there. Right, so what do we know? Well, I'm starting from this point and I say, I know when wind is blowing directly from that side. Oop, I know that's the wind. And I know that's 85 kilometers per hour. What else do we know? We know the speed of the aircraft in still air is what? 200 kilometers per hour. We also know that this airplane's resultant would like to be directly there. This is the resultant. This means this guy needs to steer the plane into the wind to end up at that spot. This airplane can only fly 200 kilometers per hour in still air. So my resultant, because it's flying against the wind, is going to be less. Now they ask us, which direction must the pilot steer the aircraft in order to fly due north? Right? So with my information, I can calculate that little angle over there. I can calculate that theta. So I'm going to use my adjacent side and my hypotenuse, so I can get cos theta equals 85 over 200. And then my theta, I'm going to do that, theta equals 65 degrees. So that angle over there is 65. Let me just write that in, 65 degrees. if I have my north-south line, this means this one is 25 degrees. Well, more or less, I'm sorry, it was 24 point something, I rounded it, so it's 25. If we look at the options given to us, D is the correct option, west of north. Is west, west is that side to north, so 25 degrees west of north, and D is my correct answer. This has always been a little bit of a tough question. Okay. What do you say, yay or nay? How many of you got that? Oh,
I got it right.
Oh, okay, sorry, I underestimated you. I will move on swiftly. Ali, are you still with us? Ali.
Yes, sir, I'm still.
Oh, fantastic. This is the question you had, right?
Yes.
On this one. I think you asked something about this. Let's quickly talk about this. A uniform horizontal beam, OX, is 4 meters long and weigh 100 Newton. It's hinged to a wall at pivot O. It is supported by X, Y, which is attached at Y. Okay, so this is my pivot O. I know it's a uniform beam. That means my weight is working in right there, 100 Newton coming in there. What is the tension in the cord? Well, I don't know. That is the tension in the cord. That's what we want to find out. When we work with moments, remember, we need to work with perpendicular distance, a force that is perpendicular to, I can do that, perpendicular to the pivot. So there's my two forces that I can use now. So I'm going to calculate, or can calculate, that's T cos 60. Let's do my calculation. So clockwise equals anti-clockwise. Two times 100, y2, well, it's in the center from the pivot, equals 4 times T cos 60. Okay, they made it easy. Cos 60 is 0.5, at least we know that. T4, and this gives me, well, 2 times 100 is 200. What does T calculate as? T calculates to 100 Newton. Tension is 100. That one. Right? Happy with that? We've got 2 minutes. Got 2 minutes. Right. Oh, what a nice question this last one was. Guys, you're working with air resistance. So for this to move at a constant velocity, you need to have the same power driving it as the resistive force. They say each one of these has a resistive force of 85 Newton. That is a what? A force couple, each one of them. Why a force couple? Because as it turns, the one turns up and the other one turns down. Against the motion is my air friction, or resistive force is what they call that. Right? Remember, what is my formula for a force couple? It is one of the forces times the perpendicular distance between it. So it says it's 3.2 meters apart. So therefore we can say 85 times 6.4. And we get that each pair of those carriages have 544. But remember, there's 2 of them. So times 2, and my net is D 1090. Right? Happy. Questions? We're running out of time. You can put the questions for me. I see there's 2 chats in there. I think it's a sign. What a sign?